And then we need the chat window, and yeah. Yeah. Okay, so it's part 4 of the introduction to programming, and let's continue on last week. So last week we talked about the while loop, about repetition with while loops, and about the more general form of while loop. Instead of just having true as condition, we talked about or discussed different kinds of conditions in while loop, and then a bit more about the break and continue statements. Then we discussed the nested loops, the idea of writing a loop inside another loop, and how we need to be extra careful with the indentation, and if we're using break or continue, how it affects only the current loop. Then we talked a little bit about strings and indices of strings, and extracting substring, extracting individual characters. And then we had a short introduction to own functions, and that's what we're going to continue with today. And so we're basically going to talk about own functions and lists today, and then there are a couple of other extra topics mentioned somewhere, but those are like the main things for today. So again, let me know if you have any questions on the way. And yeah. So the last time we discussed our own functions briefly. Let's get back to, let's see. And so we started with really something really simple, like a function with no parameters, something like this. Come on. And the basic idea was that when we have a function, then the code inside the function is only executed when we call the function like this. And then we looked at some simple examples of functions with parameters, something like, let's see, some result message function, and then we have a message here. And then what the function does, it outputs, let's say that it outputs the function, and then some exclamation points after that one. So now when we call the function, we need to provide the message, something like this, and then outputs hi all, and then the exclamation points after the message. And if we change the message to something like this, then the output also changes. So the idea of those parameters is to generalize the function, meaning that the same function can provide different results based on the parameter we provide. So let's continue on that one, and let's talk about a couple of new terms, sort of new ones, about parameters and arguments. So parameter is the variable we define in the function definition. So if you take a look at here, the function definition is in a form of there's the def keyword, which is short for define. So we are defining a function. Then we have the name of the function, and then there are always these parentheses. And if there are parameters, then the parameter variables are written inside the parentheses. If there's more than one, then we separate them with commas. Like in this case, there's a comma b. If there's only one, then we just write in the variable over there. And then we can use this variable inside the function like we use any function, any variable. So this is basically defining a variable for this function, but the difference to normal local variables is that this we don't provide a value for this variable when we are writing the function. Instead, we provide the value when we are calling the function. And the value we provide when we call the function is called an argument. So parameter is this variable in here, and argument is the value we pass to that variable when we call the function. So if you take a look at this code in here, we call this function 3 times, and we provide a different argument each time we call it, and then we get 3 different messages displayed in here. So the output of the function is based on the value we provide as an argument to this parameter variable in here. Yeah. We can have more than one parameter. Let's have something like not that one. Something like this, for example, and now when we call the output sum function, we need to provide 2 arguments because there are 2 parameters. So what if I provide arguments 10 and 20? What will the program output? Yeah, 30. Thank you. So let's try it out. Sorry, there was some extra import for, but yeah, so it's 30. Also, we can provide something like so what will the program output now if we provide 2 strings as arguments, high and all? Yeah, high all with no space. That's a good thing to notice. So it because we're using the plus operator, if we're dealing with 2 numbers, then it calculates the arithmetic sum of the numbers. If we have 2 strings, then it concatenates the strings into a new string. So basically we get high all. So these 2 arguments are concatenated. So the output of the function depends on the values of arguments we pass to the function when we call it. How about this one? Yeah, exactly. We get an error message stating that type error must be str, not int, meaning that we can combine string and integer with the plus operator. Why I wanted to do this final one is because we're going to talk about this a bit more today later. But the basic idea is that we have parameter variables, and then the parameter variables get a value when we call the function and provide arguments, which are then used as values for those variables. But other than this, these variables are just variables, so we can change the value if we want. So we can do something like this, for example. So a parameter is a variable like any other variable. The only difference is that we don't provide a value when we write a variable, when we initialize the variable, or we're basically not defining, just defining the variable, and then the value is provided when we call the function by providing an argument. Something like this, for example. Or let's do another. So what will the program output this time? Yeah, 12. So what happens in here is that we multiply the first parameter, the value of the first variable by 10, and then we add first to second, and then we output the result, which for 1 and 2 is for example 12, like you answered. So what I'm trying to demonstrate here is the fact that these parameters are variables like any other variable, so we can change their value. That's like the basic definition of variable, that the value can change as well. Okay, so this is all good, but it's not really enough for a lot of occasions. The problem with this one is that we're only outputting messages to screen, which is useful for a lot of occasions. But what if we want to, for example, let's do something, let's do like factorial of a number. So let's do this. So we have a simple program that calculates the factorial of a number, and we can test it out. Let's start it with 5, for example, and it should be 120, and it is 120. So it seems to be working. And but what if we need that factorial to calculate something else? If you want our program to calculate like the factorial of 5 plus factorial of 4 or anything like that, so just outputting the result is not enough. And what we want instead is to be able to return a value with return statement. So we want to have a function that actually usually gets some parameter values and then brings back a return or result value. And what we can do is return the value instead of outputting it. So let's just use the return statement for that one. And the idea of return statement is that this terminates the function execution and then goes back to wherever the function was called and brings back the return value. So we can do something like this, for example. We can still output it if we want to, but we can use it as part of any expression in here. So we could do something like this as well. So if you want, for example, to calculate the sum of factorial of 5, factorial of 4, and factorial of 3, then we can use the same call in an expression 3 times, and then we see that the result is 150. So return doesn't output anything on screen. Instead of, as I said, it terminates the function execution, and then it brings back the value like the resulting value of the function. And what really happens here is that the function call in here is replaced by this return value from the function. So basically this result of this call is 120, result of factorial of 4 is 24 if I'm right, and factorial of 3 is 6. So effectively it calculates the sum of 120, 24, and 6, which is 150. So the basic idea is that we can use this return value as part of any expression. Let's see something a little bit simpler function. Maybe that's enough. So if we call the add numbers function with 10 and 20, we of course, the result will of course be 30, like we saw before. But also, let's see if we do something like this. So what will the program output? Yeah, 16. You can try it out, find out. So what happens here is that we first call, actually let's output the parameters and let's output the return value before we return it. So so now if we call this one, we can see what actually happens in here. So for the first call, the parameters are 10 and 20, and so the function returns 30. So this one calls the function with arguments 10 and 20, and then the resulting value of 30 sort of replaces this call in here. And for the second call, the parameters are 30 and 30, and then the function returns 60, which then returns this call in here, and effectively this program outputs 60. So how you can and how you probably should think about this is that when we are calling the function, the return value replaces the function call in the expression. Am I making any sense here? So it's not about outputting something, it's about returning a result which can be then used in any expression like we're doing here. You should also note that return statement terminates the function immediately. So again, Visual Studio Code is sort of hinting that nothing happens here. So if we execute this one, we still get 60, but this is never output. And the reason is that return is sort of like a break statement in a sense that when return is encountered, then the execution of a function is immediately terminated, and then it returns to wherever the function was called. See something different. What will the program output? It's a bit more complicated, but there shouldn't be anything you don't know about. So just take your time, take a look at it and try to figure out what will the program output. Yeah, those are good guesses. You're close, but yeah, you're very close. Yeah, it will stop after one result. It doesn't return a list. What it actually outputs, it outputs the same number each time. There's no input for this one. If you look at the function, there's no parameter for this one. So it performs the same exact operation each time. And what happens is when we call this one, we start with index value of 1, and we have a loop that goes on while the index is more than 1000. And then inside it checks that if the index is divisible by 4, then it returns the index number. So basically what it does, it outputs 4 each time. And the return immediately terminates the function, including this loop in here. So return means that we're done with this function. Let's get back to whoever called the function, which in this case is this code in here. And so it continues the execution in here. The return 1000, which is after the while loop, is never executed in this program. So this is basically unreachable code as well, but Python just isn't clever enough to figure it out on its own. But this code line is never executed in this program because it always encounters a value divisible by 4, which is basically 4 in this case. But we could change it in a sense that let's provide the index like this. And now it provides the next number bigger than 4, which is divisible by 4, or 1000 if there's no such thing. So if we start from 500, well, that's probably divisible by 4 itself. If you don't 501, we get 504, which is divisible by 4. If we start with something like 999, then it returns 1000 because there's no number divisible by 4 smaller than, or if we provide number this big, then it still returns 1000 because the while loop isn't executed at all. But what I'm trying to illustrate here is the fact that return statement actually terminates the execution of function immediately. It's also important that you provide enough return statements. So let's see something like something like this, for example. So it's a function called get larger, and it receives 2 parameters, item 1 and item 2, and it returns. If item 1 is larger than item 2, then it returns item 1. So let's test it out with something like 140, and then if we execute it, it will output. It doesn't output anything unless we actually output it. Let's add a print statement like this, then it outputs 100. If we change the order, what will the program output now? Yeah, it shouldn't output anything. It actually outputs something. It outputs the keyword none, which basically means that the function didn't return anything. So none is the Python equivalent of saying that there's no return value for this function. So we can try to fix it. Let's change it. So let's return item 2 instead, and now it should work. So now if item 1 is larger, then it returns item 1, and if it isn't, then it returns item 2. So again, what I'm illustrating here is the fact that if you have a return inside a conditional statement, then it's important that you remember to return some kind of value regardless of what the parameters are. Like in this case, we need to return something if for all possible values. What will this output? Yeah, it outputs Python, but why does it output Python? You can test it out. What is the reason? Why is Python larger than Java? We're not really talking about programming languages, but why is the string Python? It's not about length, actually. We can. It's about the alphabetical order of the strings. So when you're comparing strings in Python, what Python does is actually it compares the alphabetical order. And it works rather well when you're using English alphabet and when you're using the same case letters. So if you're only working with uppercase or only working with lowercase letters, then you can compare two strings like this as well. How about this one? Which one is larger, Python or integer 12? Yeah, it's none, or actually it's an error in this case, a type error, and it's actually a sort of an informative error stating that larger than is not supported between instances of str and int, meaning that Python doesn't know how to compare a string to an integer, which is actually sort of logical. I mean, there's no natural way to define which is larger, a string or an integer. But this can get sort of problematic, and for this reason, we can use something called type hints. And the idea is that Python is a dynamically typed programming language, which means that whenever we create a variable like this, for example, like or age variable or whatever, Python automatically determines the type of the variable based on the value we assign into variable. So if we create a string like this, Peter Python, and then we assign it into variable name, then the type of the name variable will be string, because we're assigning a string type value into it. And in the second one, Python automatically determines that the type of the age variable is 23, or the type of the height variable is float, because we are assigning a value, a floating point kind of value into the variable. So there are also statically typed variables where we need to define the type ourselves, but in Python, Python does it for you. Anyway, for some functions, and in this case, this is actually sort of obvious, because we can see that we are assigning a string into this variable, so it must be a string variable, and this one must be an integer type variable, and this one is a floating point type variable, because we are assigning a floating point type value into the variable. But this is sort of problematic, and it's problematic because we are not assigning any values into variable yet. We are defining parameters, but then we are providing the actual values when we call the function with some arguments. And that's problematic because, as we see in here, this works with some values, but it doesn't necessarily work with all values. And for this reason, we can provide something called type hints. And the idea is that we can write the type of the values we are looking for in the function definition. The syntax is that we have a colon and then the type of the value we're looking for. So in this case, what we're doing is we are defining that this function getLarger has two parameters, item 1 and item 2, and they both should be integers. And when we're calling this one, now you can see in the Visual Studio Code that it provides the type hint in here. It actually provides the information that we're looking for two integers for this one. So I can do something like 55 and 44 or some whatever I want to call it. And it's easy because as a programmer, I now know what kind of values I need to provide. This doesn't enforce the programmer to do anything. I can still provide a string in here if I want to. So it isn't an error, but it's still a system which sort of tries to assist you in calling the function properly. So it's like a way of commenting the function, telling that this is the kind of values you should provide as arguments for this function. In the exercises in the material, the type hints are sometimes checked for, but usually not, meaning that you can get full points even if you don't provide them. But I strongly encourage you to use them whenever possible, because it makes your code more readable, it makes your functions more readable, and it prevents you on making some kind of sort of simple errors. Let's see another example, something like, so let's have an output person function where name is a string, age is an integer, and then height is a floating point value. And then let's just output something. or something we're going to use centimeters here. So now again, when I'm calling the function, the Visual Studio Code again provides me with these type hints listed in here, making it easier to know what kind of variables, what type of arguments are needed here. So age is 23 and Peter Python is 167.25 centimeters long. So when I output this, I'll put this one, we get the message something like this in here. So the whole idea of type hints is to provide something useful for programmers calling the functions, whether it's you yourself or especially when you're working on a larger project with a lot of programmers working on the same code. It's really important that you try to make the code as readable and as understandable as possible. And for that reason, type hints are an excellent tool to provide just a bit more information on how to call the function. There's also the syntax for providing the return value, which looks like this. We're not really using it in our material, but if you want to use it, you can use it. There's like this arrow consisting of what's that called, hyphen, and a larger than character, and then there's a type which it returns. And for this one, because it doesn't return anything, we could have something like it returns no type. But these are sometimes used in the material, but not that often. But the type hints are used all the time, starting from now. And as I mentioned, I also hope that you use them yourselves, because they make the code more readable and can actually prevent errors in your programs. Okay. One final thing I want to talk about or mention about functions is that it's really important, and this is something we discussed before, but once more, it's really important to make a distinction between return and print statements. So in this case, we have two max functions, max1 and max2, and the difference is that the first one returns the maximum value, the second one outputs it. And if you're only outputting a value, then you can't use it as part of any expression. But if you're returning it, then you can use it in any expression, and that makes it a lot more useful. So it's usually a good idea to return something, and in the exercises, it's actually required. If it says that write a function that returns something, then it actually needs to return something. If you're outputting it instead, then you're not getting the points from that one. Any questions about the functions before we move forward? Again, when you're working with this on your own, there's a lot of things again today. When you're working with this on your own, you probably get the idea better. But okay, we can get back to this later if you want to. Then let's talk about something else, something useful as well. So we've been talking about the fact that we mostly write computer programs to perform a lot of operations in a short time, or to handle a lot of information, a lot of data. And if you talk about a lot of information, if you talk about a lot of names, for example, let's say that you have 100 names you need to manipulate somehow, you could write a separate variable for each of these, like name1 equals to Python and name2 equals Java, and so on, and until name 100 equals something like or something. But this isn't really convenient. The problem with this one is that if you have 100 separate variables for names, and then you want to perform the same operation for all names, let's say that you want to convert them all into uppercase or lowercase, or add something into them or whatever, then you need to write the same operation 100 times. You could probably do it 100 times, but if you have like million names, then you definitely don't want to do the same operation. Write the same operation 1 million times in a row. So instead of having individual variables, when we have information that's somehow connected, meaning that we have sort of similar kind of items we can use lists instead. So I can do something like this. We initialize list, we store it into variable, and the list is written inside these square brackets, and then I can just type in the values or items. I forgot them already, but let's just something like this. And now I have a single variable which I can use to access all these items. I can do something else. Let's have something like, well, wait, this is fine. So there can be any number of items in a variable. We could have a list of ages that contains six items, so we could have something like temperature, like this. So we can have a list containing strings, list containing integers, a list containing floating point numbers, excuse me, or whatever we need. So we can create a list by writing square brackets and then the items inside those square brackets. If there's more than one, then we separate them with commas. We can also create an empty list like this. And then we can populate it later. Because lists are dynamic data structures, meaning that we can change the content of items, we can add new items, we can delete items, so we can change lists. A lot of the operations we perform with lists are similar to operations we did with strings last week, which make things a little bit easier for you. You don't need to learn that many new things. You can just use for example, the len operation for finding out the number of items, also work with lists. I can do something like this. And so what will this one output? What is the length of list names? Yeah, it's 3 because there are 3 items in there. And similarly, the length of ages, for example, is 7. There are 7 items in there and so on. And the length of results is of course 0 because there are no items in that list. We can also access individual items by using the index number. So what will the program output? If you think about how we access it outputs be the Python because that's the first item in that list. Similarly, third item in that list is that Helena Haskell, or we can also use negative indices if we want to. So if you want to access the final item, we can use -1. That one, it's several times. That one works as well. So this is similar to what we did with strings. But the difference in here is that we can also change the items. We can do something like this. And now when we execute the program, now when we output the list of names, you can see that the first name has been changed. So instead of Peter Python, there's now a different name over there. So we can't do this with strings because strings are immutable. You can't change the string, but you can change the list. And oftentimes you want to change the list. So we can change the items over there. We can also do something like what happens in here? You don't need to type the whole output. Just tell me what's happening in here. What does the program do? Yeah, it will add then to the second date, to the second item in this list, which is this one in here. So now if we take a look at the output, we can see that instead of 25, it's now 35, the second item in there. So we can change the items if we want, and oftentimes we want to. So items are indexed similarly to characters in a string. So first item is at index 0. We can get the length by using the len function like we did before. We can also add items to lists. Let's add this one and then see what it looks like. So now instead of 3 items, the list now has 4 items with the 4th one added with the append method. So it's possible to add new items in a list, and oftentimes we want to do that as well. Let's see, we can write a program with, let's say we have a results list, start with an empty list. Let's have a names list instead in this case. Yeah, the append always adds the new item as the last one. Let's take a look at this one. Query the user for a name. Let's see that if name is an empty string, then we break out of the loop. If it isn't, then we append the name at the names list, and then finally we can display the whole list. Let's see how this works. So let's give some names. Then empty one, and we can see that the names are included or inserted in the order that I typed them in. So the append always adds the item at the end of the list. If you want to insert an item somewhere else, you can use the insert method, where you first provide the index and then the item, and then that item is inserted into that given index. So basically I have a picture about that one. It also means that, let's say that we have a list points with these items 10, 9, 10, 8, and so on. And then we insert a new item 12 at index 2. So basically it means that this is the new item in here, and all the items starting from index 2 are moved one step forward. So item at index 2 becomes item at index 3, and so on and so on and so on. So inserting something in the list can mean that items following, or does mean that items following the insert point are moved one step forward. And but if you append something, then the length of the list increases by 1, but the item is always inserted at the end of the list. Let's see another example. Well, it can be one. So let's see, when we execute this one, we get a list containing all the values from 1 to 10, because those are the values we iterate through in the while list. But if we instead insert in the beginning of this one, then we have a list containing the numbers, but in the reverse order, because we always add the new item at the beginning of the list. But if you think about these operations, then using append is way more common than using insert, because that's how we use lists in the real life as well. If you think about lists, you probably have a list somewhere, and when you're adding items in a list, you add them at the end of the list typically. But it's possible to add an item anywhere. You just need to use the insert statement for that one. There are 2 methods for removing items from a list. There's a pop method, which removes and returns an item at given index. So let's have a list of numbers again, see how it works. So let's remove some items. like this. So what do we have left after this one? What items are in the list after this one? Yeah, it removes the first 3 items, 1, 2, and 3. So 3 items from, it removes the item at index 0 3 times. We can also output the list after each removal. So that you can see what happens. So after first removal, there are items from 2 to 10, then the items from 3 to 10, and finally after the third removal, items from 4 to 10. So this is useful if you know where the item you're removing is. There's also the remove operator or method, sorry, not an operator, which basically removes the given item from a list. So this one actually removes the item 3 from a list. So we get list with items 1, 2, 4, 5, and so on. If there's more than one such item, it only removes the first one. So if you take a look at this one, it only removes the first item 1 from this one, not the others. So if you want to remove them all, then you probably need to write, for example, a function yourself. Do it list, and then it's this an integer, and then as long as item is in that list, we remove the item from the list. And now we can call this function and provide the list, and then item 1, and now it should remove all the items with value 1 from the list, which it does. So basically, you could, if you need to perform a similar operation various times, you can probably just write a function for that yourself. When you're removing something with remove, it needs to be in the list. So if I have again a list of numbers, and I try to remove value 8 from this list, it will give me an error stating that value error list removes X not in list. So you can't remove something that's not in the list. How to fix this? How to find out if the number is in a list? What did we do when we tried to find out if a certain substring is in a string? There was an operator for that one. Yeah, we could use index, but there's even more simple one, I think. Find, yeah, but even easier is just state that if a in numbers, which basically is to find out if the item is in a list. And again, if we're doing this a lot, we could write a function where we check if the item is in a list and then only try to remove it if it is over there. When you're removing something from a list, you need to be really careful because the length of the list is decreased by 1 point. And if you're iterating through the list, then it means that something can get something can break. So for example, removing all even numbers. There's an exercise about that, so I'm not going to show you the solution, but the basic idea is that you need to iterate through the list one item at a time and check if you want to remove it, and then remember that the length decreases when you remove it. But I'm not going to show you it because it's a good exercise. It's something you need to do once yourself. You're probably going to do the same error, at least most of you. But after you've done it once, you probably will remember it when you got it solved the next time. It's possible to sort the list in the natural order by using the sort method or the function sorted. Let's get a list of numbers. Something like this, and if we call the sort for numbers, and then we output the list of numbers, then you will see that it's in natural order from smallest to largest, which is really useful in a lot of occasions. If we need to remember the original order, but also get the sorted one, we can use the sorted function, and now we get another list, new list where the items are in sorted order, and then we can also keep the original list where the items, if the order is meaningful. For example, let's say that you're storing something from a sensor once every minute or once every day or something like that, and you want to know the exact order, but then you also want to sort them from smallest to largest, then you can use the sorted function like this to create a new version of the list with items sorted. Sorting works with all the sort of Python's like built-in types, like with numbers and also with strings. So you can sort a list of strings, then Python tries to put them in alphabetical order. So it's basically the same we talked about comparing two strings to each other. If you think about iterating through lists like this list of numbers in here, we can use a while loop like we did last time. Then we just need to remember to increase the index, and this way we can access all the items in a list one at a time, so we get all those numbers one after another. This one works, but there's an easier way to iterate through any sequence, and it's a for loop, and what it looks like something like this: for number in numbers, and then let's just output the number, and this gives us access to all items in a list one at a time. So basically what happens in a for loop, it starts by looking if there are any more items to iterate through in a list. If there are, it picks the next item and stores it into variable, in this case the variable number, and then it executes the code block, and then it again checks if there are any more remaining items in a list, and it keeps on doing this until it reaches the end of the list. So this is really useful if you need to access all the items in a list in order from the first to last. This one also works with strings. This number in here, it's variable name. So you can use anything, whatever we want in here, like for n in numbers or something like that. So it assigns all the variables, all the items in a list to this variable, and then it one at a time, and then it executes the code block. So the content of variable one n changes each round. So this is really useful if you want to access the items one at a time. It's a lot easier to type if you think about the while loop. I mean, you can still use the while loop if you want to, but this one is definitely more useful or easier to use. It also works with strings. We have a name like this. And again, we just provide a variable name, and it's a good idea to provide a meaningful variable name, and then we can access the characters in a string one at a time, P, E, T, E, and R. We change the name something else, then we again get the characters in that string one at a time. Again, this is useful if you want to iterate through all the characters in a string and, for example, calculate all the digits or all the vowels or whatever you're working with. Probably should be a character instead of that one, but it's a variable name, so whatever you want to use. What more? Oh, something in addition to the for statement, you can use something called a range a function with the for statement to, if you don't need a list of numbers, but you want to iterate through a list of numbers or a sequence of numbers, you can create an iterable sequence with the range function and use it with for statement. So basically we can do something like this. So this gives us all the numbers between 1 and 100. The endpoint isn't included. And then we can output them one at a time. So if you want to calculate the sum of numbers between 1 and 1000, we can do something like this, and then we can find out that the sum of all numbers between 1 and 1000 is 500,500, which is actually a sort of an interesting number. Didn't know that one. But yeah. So basically, the range function can be used whenever you need to iterate through a certain range of values, but you don't want to create a list containing all those values. So it just creates something called an iterator, which can be then used to iterate through, or generator, which can be used to iterate between those values over there. Okay, couple of more things. Lists can be sliced, so you can get sublists exactly like we did with substrings. There's nothing new in here. We just provide the start and end point, and then there's a colon between them. So this is exactly like extracting substrings from a string. What we talked about earlier was that strings are immutable, but lists are mutable, meaning that we can change the content of a list like we've been doing here. We've been adding new items into a list, and we've been deleting items from a list, and we've been changing the values of items in a list. You can't do this with strings. So if we have a string like and we want to change the first letter, we can't do this. It will give us an error stating that str object does not support item assignment because strings are immutable. You can't change the content of string. But what you can do is create a new string, something like this. And we can even assign the new string in the same variable. So we get the name with the capital P in the uppercase P in the beginning, but we don't really change the string. Instead, what happens here is the similar thing that's happening here. If we have a string hey, and then we append or concatenate an exclamation point at the end, it creates a new string with the content hey and the exclamation point. The original string just is left somewhere in the memory to be removed later at some point. So strings are immutable, lists are dynamic structures which can be changed. There are some useful methods. I'm not going to maybe show them to you because there's a lot of things happening again this week. It's a good idea to try them out yourself. But the count returns the number of items in a sequence. So if you want to know how many substrings, certain substrings you can find in a string, you can use the count. There are examples in the material. Replace creates a new string with given substring replaced with another substring. Maybe I can show you. So if you have a sentence, something like hi all, and we can do something like this. No, we don't want to do that. Let's replace the hi with hello, and then when we output the sentence, for some reason I can't write anymore. Output the sentence, then we get hello or instead of hi all. So this is again useful. This also replaces all the occurrences of a substring with a new one. but you need to use it a couple of times. One final thing I want to talk about today is about this formatting output and about something called f-string. So if you take a look, you've been all doing something similar to this one. We'll be actually doing something similar today. We had this example of a function that outputs the person's information, the name and the age and height, and this is sort of painful, adding all the information in all the variables with string, like all the pluses and all the str functions and so on. So, and if you're using comma, then you get all those excessive spaces and so on. And the answer, to make your life a little bit easier, so there's something called an f-string. An f-string means that we can insert values of variables in the string. So let's say that we have a name and we have age and we have byte. So when we're using f-string, we provide a lowercase f before the quotas, and then we can write something like, hi, my name is, and then we just type the variable name in this, what do you call this parenthesis? Curly brackets, I think. Yeah, thanks. Something like this, for example, if you can. And when we execute this one, it then inserts all the variable values over there. So this one is probably easier to use than using all the plus and comma operators and str function and so on. At least I prefer this one. Yeah, they were introduced in the exercises a bit earlier. We probably in the first year we introduced them in the 4th week, and then we decided or realized that they are so useful that it's a good idea to introduce them before this one. But this is sort of like a reminder. Anyway, I think it's a good idea to use them. They also have other usages, like the fact that you can reduce the number of decimals output when you're outputting a floating point number and things like that. But yeah, any questions about this week's things? Again, as I said before, there are a lot of things, but the main things this week, what I want you to especially know, are the function parameters and return values, and then the basic idea of lists and how to use them. And then there's a lot of stuff about those, but you can just try to learn them one at a time. There's an example in material about reducing the length of a floating point. I think I can't remember the exact syntax at this moment, but it's with an f-string as well. So just take a look at the material. Any other questions? Well, let's be reactive and search for it. Stack Overflow is also always a good bet. So let's see. So if you take a look at this one, can you see it? There's in f-string, there's the a variable and then a colon and then the number of decimals. So we can do something like what was the syntax again? It's been a while. Something like this, for example, and even if we have a lot more decimals over there, then for the output we only get 2 of them. So you have a variable, a colon, and then dot, and then you display the number of decimals, the maximum number or the exact number of decimals you want to have after the dot over there. Learning to Google things is essential when you're programming, because this is, for example, this is a kind of thing that I've done this various times. but the syntax is something I just, for some reason, can't seem to remember. But there's no point in remembering it if you can Google it. I mean, it doesn't matter if you remember it, but there's no point in trying to remember it if you can Google it in like a couple of seconds. And this applies to a lot of things in programming. There's a lot of this syntax and a lot of these names of functions and methods and so on, which you may not remember, but it doesn't matter if you know like the basic principles, and then you can Google for details on specific things. That's what all the programmers do. And Stack Overflow is very often the place where you want to take a look after Googling it. There are always a lot of useful information found in it. Okay, I'm going to